Narrow or weak artificial intelligence. Machines that exhibit a limited extent of intelligence to accomplish a single or certain simple tasks are said to have narrow or weak intelligence. Such machines are deployed to perform some repeated tasks. Some examples are performing web-wide search of content, example Google search, recognizing face among several single image shots or group images, self-driven vehicles, voice interface-based assistants such as Alexa and Siri, any logic-based game such as a card game slot equipped with artificial intelligence loaded with the possible permutations of different sets of cards and rules of the game, a robot collecting empty food trays from the tables in a restaurant, a car driving simulator, a website suggesting similar products depending on the items bought by the user earlier. Key features of narrow AI. 1. Perform a dedicated assigned task. 2. Limited to a particular field of application. 3. Has a predefined set of functions. IBM Watson. Watson by IBM is an AI-based question-answer system that answers the questions asked in natural language. It is developed by the team headed by David Ferrucci. Its first successful implementation was done at Memorial Sloan K Cancer Center, New York, where it helps in lung cancer treatment. Watson is able to gather massive data from encyclopedias, newspapers, dictionaries, and databases. Then it analyzes the immense amount of data to generate various hypotheses which help it to answer the new questions posed by the users. It runs on Linux operating system and 90 powerful server computers of IBM equipped with 16 TB RAM and 3 5 GHz 8-core microprocessors. Strong or generalized artificial intelligence. Machines with strong intelligence are capable of not only think like humans but also able to retain the learning developed by the tasks accomplished. Such learned intelligence is used to solve the same problem in different scenarios. It is this type of intelligence which makes for the scope of actual AI to be developed in future. Such machines can be thought of having intelligence in the beginning like that of a child, and later they learn and grow their intelligence like that of an adult. Some expected scenarios as an outcome of strong AI could be a self-learning diagnostic system loaded with information regarding diseases and possible symptoms along with rules to diagnose the diseases. An airplane training system that functions without the help of a trainer. An intelligent chatbot that understands customers' needs and suggests solutions by its learned intelligence. A teaching robot that learns by answering students' queries and thereby enhancing its teaching skills. Key features of strong AI. Perform variety of tasks in changing context like responding to a question in different ways. Smart like humans, think and respond like humans do. Capable of applying retained knowledge to solve new problems. AI types on the basis of functionality. On the basis of functionality, artificial intelligence can be classified into 4 types: reactive machines, limited memory, theory of mind, self-awareness. Reactive machines. As the name suggests, a reactive machine knows how to respond to a particular stimulus input on the basis of a set of rules and the logic to apply those rules in all possible scenarios. They show the most basic type of AI. They do not store learning by previous problem solving. Computers that play strategy games against humans are examples of reactive machines. IBM Deep Blue. In 1997, the world chess champion Garry Kasparov was beaten by IBM's Deep Blue, a chess-playing supercomputer. Earlier versions of Deep Blue were beaten by Kasparov. Deep Blue was capable of computing 200 million positions or moves per second with a processing speed of 11 gigaflops. The Deep Blue program was written in C programming language and it ran on AIX operating system over 480 VLSI chips. Limited memory. Such machines are equipped with the logic of sensing the changes occurring around, such as an object changing its place or position at a distance. Machines with limited memory cannot retain the learning. The observations or logical details related to completing the task are not retained by the machine to apply them again next time. Next time, in the same situation, logic to resolve the problem is executed afresh. Self-driven cars, chatbots, and customer response systems are based on limited memory functionality. Self-driven car, Waymo. Google's subsidiary Waymo developed this self-driven car after research that began in 2007. After several test drives and improvements, the self-driven version of Waymo with no driver and any human help was tested successfully on real roads in Texas. Waymo is equipped with a rooftop camera, LiDAR, to create a 3D vision for the car 200 meters around. Overall, it has 6 such sensors. It has GPS sensors to help it assess road conditions and lane positions. Gyroscopes, tachometers and altimeters fitted inside the car help it maintain its direction and balance. The car is able to identify other vehicles and obstacles in front and around. It identifies traffic signals and hand gestures made by other commuters. Amazon Alexa, Google Assistants, Apple Siri and Microsoft Cortana. Alexa, Assistant, Siri and Cortana are voice-driven virtual assistants by their respective companies. They are just like voice-driven wizards, equipped with speech recognition and natural language processing technologies, which can do a lot of things for you, such as answering almost any question on any topic, set reminders for you, doing weather forecasts, playing your preferred music, delivering messages, switch to various channels such as sports, education, market, entertainment, etc. Today, Alexa has around 90,000 functions and skills that it can perform for the user. Google Assistant identifies objects, songs, user preferences, and allows e-commerce by voice. Users can set voice shortcuts for common commands. Siri can navigate locations. Cortana is available with Windows 10 systems to provide voice-based commands and search features using Microsoft's search engine Bing. Theory of mind. Machines based on this concept of intelligence are capable of interacting socially. They are able to respond suitably to others by exhibiting understanding of their emotions and gestures. Research is ongoing in this field and certain very encouraging results have been achieved, but still a lot more needs to be done in this direction. Humanoids. Humanoids are the robots that look like humans exteriorly. The humanoids closest to humans in looks and expressions are androids. Humanoids today are used for various purposes like teaching, ocean exploration, Ocean 1 by Stanford Robotics Lab to carry out search and rescue missions, Atlas by Boston Dynamics, sports soccer playing robot Neo by Aldebaran Robotics playing RoboCup Standard Platform League, biological and chemical tests, Petman by Boston Dynamics, caregiver robots for patients and senior citizens as companions and respond to emotions, Robert by Riken and Sumitomo Rico, Pepper by SoftBank's Robotics. Sophia by Hanson Robotics appeared in talk shows and one citizen of Saudi Arabia. Self-autonomous robot Mitra by Invento Robotics, India. Self-awareness. Such machines are truly intelligent machines. Such machines, of course, do not exist as this book is being written, but endeavors to develop machines that exhibit intelligence exactly like us humans are ongoing. There is another form of AI called artificial superintelligence. Option. There is another form of AI, CA with artificial superintelligence, which is the highest form of AI using which machines will surpass human intelligence owing to their speed, capability to process astronomical amount of data, and self-evolving smarter algorithms. What kind of world would that be with super AI machines around is hard to predict. Artificial Neural Networks, ANN. In 1954, at Massachusetts Institute of Technology, MIT, Farley and Clark developed a 128 neurons system which could memorize simple patterns and then distinguish one pattern among many. The algorithm was developed in such a way that each neuron was able to hold the information taught, fed repeatedly to it by a computer program. Computer program repeatedly fed various combinations of patterns to the artificial neurons system, so that they retained possible combinations of various features of patterns. Machine learning, ML. ML is not an AI concept. It is a subset of AL that enables a computer system to learn from experience without programming it further. This technique is used to make computer perform accurate predictions after analyzing the input given to it. Machine learning has following approaches. Supervised ML. In this approach, the computer system equipped with ML ability is fed with the inputs and also informed about what prediction it is supposed to do. After the prediction, the new findings are stored by the machine for doing any new predictions in future. For example, a routing software learns to find the fastest possible route by checking the patterns in traffic data and road condition, street, flooded, bad road, etc. Unsupervised ML and deep learning. In this approach, machine is fed only with input data but not the desired output details. It uses input data to analyze enormous amount of data in its knowledge base to find out any useful patterns it can. Such machines are considered more intelligent and their process of data analysis is called deep learning. After prediction, the output is stored by the machine to use it for performing any future predictions. Deep learning machines are helpful in finding new trends and patterns in data. For example, a machine can predict which students are likely to show improved or declined performance in next exam by analyzing performance data of the students in entire school. Reinforcement learning. This type of learning is based on the concept of reward and punishment. A machine learning the steps to accomplish a task learns the correct steps by failing and passing at each step. For each failure, there is a punishment which helps the machine realize that the step was wrong, while a reward helps machine learn the right step. For example, an AI system is designed to find the shortest and fastest route between 2 points. For every obstacle it encounters, it learns that the movement or turn was wrong, punishment. So next time it tries the alternate path which lets it move further distance, reward, until another obstacle. Eventually the learning of correct route is reinforced. Robotics, industrial automation, supply chains, games, information compilation, automated vehicles are some practical applications of reinforced learning.